Hello and welcome to Programming Rush. Today in this video, we are going to learn binary search in C++ programming. So we are doing this in C++, but the same applies for Java, Python and any other programming language. So what is binary search and why do we use it? Binary search is an algorithm used to find an element from a sorted array. The array should be sorted, and we use this because this is a very efficient algorithm. The time complexity is of log n. So why do we use it? I have said that it has the time complexity of log n. So we will see here an example that how does the binary search works. So let us say we have an array here and the key element we want to find is 23. Let's take the example of 23. Now 23, let us find which position it appears. Taking the first position as 0, then 0, 1, 2, 3, 4, 5. So 23 appears in the 5th position. Now we have two integers, left and right. The left is the left number, means the left key, and right is the right key. So we have total 15 elements here, starting from 0 to 14. Now we introduced another element, another number, that is mid, which stands midway of left and right. So we can find here that our mid is here from by calculating is left plus right minus left by 2. That means mid is equals to 7. So in this case, case 1, the left is 0, right is 14 and mid is 7. Now the 7th element, 1, 2, 3, 4, 5, 6, 7. Sorry, I should start from 0, 0, 1, 2, 3, 4, 5, 6, 7, the 31. So mid becomes the 31, number 31. Now we are going to check if the 31 is equals to 23, the key element, or not. If true, then we are going to return the index. We are going to return the mid, that's the index of this 23, but this is not true. So we are going to check if 31 is greater than 23 or lesser than 23. If 31 is greater than 23, we are going to shift our search from this whole array to just this before 31, that is 1 to 25. So what we are going to do, we are going to shift our right to mid minus 1. And why we are doing so? We are doing so because we know that our array is sorted. Now if our right, we have understood that the mid is larger than the key element. Now that means that the right element will also be, that means we don't need any element after this, and including this is not equals to key element. So we need to shift our right so that we can get our key element, and our key element is something between this 1 to 25 and not from 31 to 58. And so this line executes, and if this line becomes false, we have another statement which we are going to see here now. So our case 2 becomes left remains 0, right becomes equals to 6, and the mid becomes, now according to this formula, the mid becomes 6 by 2, that is 3. Now what is the 3 here? 0, 1, 2, 3. The 0 is, we are going to again check this, that if 0, 1, 2, 3, the third element is equals to 23 or not, that is 5 equals to 23 or not. But this is not equals to 23, so we are going to check this. if 5 is greater than 23 or not. But in this case also the 5 is not equals to 23. So we are going to check again that if 5 is lesser than 23 or not, and this time it is true. So we are going to shift our left index to greater than mid position. Why? Because we know that in this position that our 23, that the key element should be more than this 5. So we don't need this now and we don't need this. So what remains is this small array. In just 2 steps before we had this huge array of 15 numbers. Now we are left with an array of just 3 numbers. Now the case 3 comes here now. Let me copy and paste this, and as we can see now the left becomes mid plus 1. Our mid was 3, so our mid becomes 4. Our right remains same, and now our mid becomes 4 plus 6 minus 4 by 2, that is equals to 5. Now what is our fifth number here? 1, 2, 3, 0, 1, 2, 3, 4, 5. So our fifth number is 23. Our fifth number is 23. So what we are going, now the fifth becomes 23. So we are going to check that if 23 is equals to 23 or not. And in our case that 23 is equals to 23. So we are going to retain this mid position, that is 5. And this is the searched index. And if it was not that one, then we are again going to reduce reduce our size to just this element or just this element. And if it was not the case that we didn't find the element does not exist here, so what happens at that time? So at that case our left becomes greater than the right, and this is not feasible because what we are doing here, we cannot swap the positions of left and right. Left should be always here and right should be always here. Means left should always be smaller than right or equals to. But in this case the left becomes more than right, which is not possible. So what we are going to do in this case, we are going to return a -1, and -1s for our case means that we didn't find our element. So this much explanation is enough for this binary search algorithm, and we are going to now implement this algorithm in our C++ code. So first our return type should be int or anything of int like long or short. Now we are going to name it binary search, and now we need 3 things. First the array, then the key element that we are taking from the user, and the size of the array. So we are going to take an array, we are going to take here the key element and the size element. Now we are going to create 3 variables. Left equals to 0, and right equals to size -1. Why we are doing -1? Because we know that the total length is 15, but we are doing from the 0th index, so the right should be decreased by 1. And now we have the third variable int mid. Now what we are going to do, there are 2 approaches for doing this binary search. One is recursive and another is iterative. In this example, in this tutorial, I am going to proceed with the iterative one, and the reason is that iteratives perform well for huge sets. Although this algorithm is highly efficient, I prefer to do iterative one, and I encourage to do also if possible. So while left is lesser than equals to right, this is our terminating case. If anytime the left increases, the left is more than right, then we are going to stop this while loop is going to stop. Now But first of all, we are going to calculate our mid. And what is our mid? Mid is our this value. Now, first our check condition is if array, the mid position element is equals to the key element or not. If it is so, then we are going to return that element, return the mid position, sorry. Now, we are going to check if mid is greater than the key element. What does it mean? That the array beyond mid is not needed to us. Our key lies before it, our key element. So in that case, what we are going to do? We are going to make right is equals to mid minus 1. No. Else, what is the case? In this case, that array is this mid elements must be smaller than this key element. Why? Because we have checked if it equals to or not, if the mid is greater than or not, and the remainder case is if array at the mid position element is smaller than the key or not. And if it is so, we are going to make the left means the array before left is not needed anymore. And in this case, we are going to increment our left position pointer to the mid plus 1 position because the mid element is not needed anymore. And we have in the while loop a return case that if it becomes true, then we are going to return the position. Else, if we do not find that number, then we are going to return -1. Simple. So this is our simple code for binary search, which will find our element in a sorted array. This should be kept in mind that the array should be sorted. We have taken here an example array of size 15 elements, which is sorted 1, 3, 4, 5, 6, 23, 25, 31, 35, 38, 40, 42, 43, 50, 58. This array is sorted and we need a sorted array. So let us build this code, and now let's enter a key element here. Let us enter here 25. Oh, I'm sorry, I have not calculated this. Let us calculate it. Binary search array, key element, size, yeah, 25. Yeah, the position is 6. Let us see it. 0, 1, 2, 3, 4, 5, 6. Yeah, 25 comes in 6th. Now check a number that is at last 58, 14. Yeah, it finds out. Now let us try it again with a number which is not present. Let's pass here 45 -1. So our code works very well. We have seen that all the outputs work, 25, all the inputs work, and this is the code for, let us zoom in out. This is the code for binary search. If you like the tutorial, please like this video, share it among your friends, and subscribe Programming Rush. And if you need this code is available in the description. Make sure you check if you need this. And thank you. See you in the next video.